Today we're going to talk about measuring pressure in cylindrical pressure vessels. So not mechanics just yet. Still, we're going to do some different statistical tests. So I really like to grill, but my grill uses a cylindrical pressure vessel filled with propane. A bit wary of catastrophic failure of cylindrical pressure vessels via the hoop stress. Can't help myself. Which way will it fracture? Should get pulling here. Hoop stress is always twice as large as the longitudinal stress. Anyways, you'll be seeing that a little bit later on in this course. So, trying to decide between buying my propane tank at Lowe's, Home Depot, or Ace Hardware. So my press-out hips are tied to test for multiple propane tapes, fill them up. So I run 17 measurements for Lowe's, find them have a mean 17 megapascals, standard deviation of 1 megapascals. 11 Home Depot, mean pressure would be 16 megapascals, standard deviation of 1 kilopascal. I test 28 samples of Ace Hardware tank and find a mean of 25 megapascals with a standard deviation of this 28 samples. So right off the bat, I want to start accumulating these values. So I run, N for L, so number of Lowe's measurements, 17. X bar, so I'm just going to call this X of Lowe's is equal to 17 megapascals, and my S of Lowe's is 1 megapascals. My number of Home Depot H is going to be, 11, and H equals 11. My X of H is equal to 16, and I 17 measurements, 16, and then I have a standard deviation Home Depot of basically 0.01 megapascals, putting everything in megapascals, so because that's a kilopascal. I have my number of samples, N of Ace is equal to 28. I have an X of A equals 25, and then I have an S of A that equals to 10 megapascals. So those are kind of just the values I want to calculate and basically have in my Mathematica notebook. So when I want to grill, I want to make sure that my mean pressure will not exceed 17 megapascals at a 1% significance level. What propane tanks will work, if any? So my H naught here, H naught is going to be that the population mean pressure is 17 megapascals. The alternative hypothesis is that U is less than 17 megapascals. So now I'm going to run my hypothesis testing. I know that this is a left-tailed test, so my alpha is equal to 0.1, and I need to find out my T alpha new values for these different parameters, or these different samples, and see if that matches the T experimental. So let's go ahead and calculate those out. So I have, let's go ahead and actually find some of those values. So I need to find for Home Depot, so that's going to be a T of 01, or actually for Lowe's, of 16. That is going to be equal to, and I'll show this for one example, and then we'll stop looking them up each time. So let's go to my lecture 4. Actually, let's go to our present here. So T of 01, so right here, and then 16, that's going to be 2.583. And remember, it's a left-tailed test, so we're going to want the negative value. So minus 2, so T of 01 mu 16 equals minus 2.583. We're going to do the same thing for T 01, a nu of 10 for Home Depot is going to be minus 2.764, and a T of 01, a nu 27 is going to be minus 2.473. And you can look those up. Actually, you can double check them right here. So 01, 10, so 2.764, and then of 27 is going to be 2.473. So those are my bounds. So I need to now calculate my T experimental. So for Lowe's, it's just going to be X of L minus the mean, which is our H naught, our null hypothesis, which is going to be 17. So I need to look here. So let's go ahead here, divided by my standard deviation of Lowe's, divided by square root of n. NL here, and that's just going to be 0. So if we look back at our hypothesis testing, let's go over here. That's why this picture is so good. So we are in the do not reject H naught region. So we are not rejecting H naught. It does not come from, so that will not work. So let's go ahead and look back here. H naught, that is in the do not reject H naught region, as we can see here. Let's do the same thing now for XH for Home Depot, SH, and NH. That is very, 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 very reject H naught. So it definitely does come from less than 17, which again makes sense looking at here and looking at such a small standard deviation. And then let's look at ACE. So that is reject. Let's do this and look at it numerically. Oops. And 4.322. So this is positive, do not reject. So again, that should make sense looking at this region here. So that is the first question, part of this question done. So do any samples come from a population with a mean pressure of 16.5 megapascals at a confidence interval of 95%? So here, the only thing that's changing now is I'm doing a two-sided test because my alpha is 0.05. I'm saying does it come with a mean pressure of this? So it's going to be alpha over 2. So we're looking at a T here of 0.025. So let's go ahead and go back again to our expression here, our equation. Let's find out those values. So I need T of 0.25, T 0.25 nu of, again, 16 first. So 0.25, 16, 2.12, 2.12. T of 0.25, a nu of 10 is equal to 2.228, and then a T of 0.25 nu of 27 is equal to 2.052. So that's our values right here. So let's just run through this, basically these expressions again. So the only thing that's going to change here, which we'll see, is now our null hypothesis is this 16.5, and we're doing a two-tailed test. So 16.5, 16.5, and 16.5. And then let's go ahead and calculate these values out. Let's look at our this picture right here. So two-tailed test, where do we fall? So what is our, for here, it's 2.12. So we could see that we are in the what region here? So 2.12, 2.12. So we are in the do not reject region. We fall in between. Here, we are definitely in the reject region there. And then finally, you can see this falls out the bounds as well. So only this one could come from our first sample. At a 95% confidence interval, we are not rejecting H naught, so it can come from that. The rest of them we are rejecting. So let's look at the next problem right here. One. What is the 99% confidence interval of all the means for all three propane tanks? So we need the 99% confidence interval. So now we're looking at only thing that changes. Actually, this is a little bit of a different problem, but this is our alpha is equal to 0.01. I'm looking for basically the interval, the bounds for the true population means. That's so I'm looking at an alpha of 0.005. So let's go ahead and look at those expressions again. So when I look back at this table here, let's go ahead and get into our table right here. So I now have my T of 0.05, a nu of 16 equals 2.921. T of 0.05, a nu of 10 equals 3.169, and a T of 0.05, a nu of 27 equals 2.771. So those are those values. To get the bounds, these are essentially my precision errors. So I'm going to do T 0.05 nu of 10 times, and then I'm going to have X my lows plus this times my S lows divided by square root of n. That's it. Let me put this in parentheses because I'm paranoid about putting parentheses. Number of lows L. That's it. So plus, I can do the same thing for minus. And now I'm going to grab these values here, and I'm just going to repeat and change. Excuse me, not new of 10. I need a new of 16. That will change things just a little bit. XL, so this is XH, this is H, just changing everything here. Should have made a nicer function, but again, no style points. On the exam, you can go through it a little bit faster than this, but here, there we go. And then finally, do the same thing, just plugging in. Again, nothing too mathematically complex. Again, you can set up the equations if you're running out of time. X, A, 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 A. And those are it. Those are your bounds. So let's look at the last part of this problem. Are the Home Depot and Lowe's tanks significantly different at a 90% confidence interval? So this is where you're going to have to pull out your old friend. And actually, I'm going to go and look it up. Hopefully I have it here. Let's go ahead, do my lecture 4 notes. Yep, luckily I have this. I'm going to do comparing samples, so you know what I'm going to have to utilize. Actually, it's going to be lecture 3 notes, excuse me. Lecture 3. Oop, that's a polymer lecture 3. Here we go. So I need to use this expression right here and this expression right here. So I'm going to copy these, get out of here, go back to my nice value here, T experimental, new experimental. So let's get back to the question. Are the Home Depot and Lowe's tanks significantly different at a 10% confidence interval? So again, only thing that changes here is my alpha for this problem. Alpha is equal to 0.1, but it's basically a two-test comparison. So we know that alpha is equal to over 2 equals 0.5. So I'm going to do my same procedure for hypothesis testing, except my alpha is going to be 0.05. And my nu, we're going to figure that out right now. So we're comparing the Home Depot and Lowe's tank. So my nu is going to be my S of Home Depot, my S of Lowe's, N of Home Depot, N of Lowe's. So my nu is 16, right on the dot. Nice. So it's going to be 16. Oops, excuse me here. Let's get rid of this guy. Nu 16. And that is going to give me a value of, let's go ahead and look it up here. Let's go back to this presentation. So of 05 and a nu of 16, 1.746. So let's go and check that. 0.746. So this is going to give me 0.746 right here. So let's calculate now my T experimental. So my T experimental, I'm comparing again the Home Depot and Lowe's. So XL, SH, SL, NH, NL. So remember HL, HL, HL. Calculate that. Minus 4.21. So let's double check. Again, two-sided test. So where does that fall? Where are we at? So this value is minus point. We know that the two-sided test here minus 1.746. So these are bounds, minus 1.746 plus 1.746. So we are in the reject H naught region because right here our T experimental outside of those bounds. So we reject H naught. So they are not similar. They are indeed different, which is again what we might expect by looking at some of these values. So that's it. That's problem 3 in a nutshell. So again, a little bit, we need to make sure our calculations are correct. Make sure you're doing alpha over 2, greater than, less than, confidence intervals. But that's kind of the gist of the problem that you might expect. So thanks, and I'll see you on the next one. Bye.